right, so I've successfully made AuPd wire here. I checked, and it makes rainbows now, and it didn't before I started. And you can see on this end that it's pretty much unscathed. But this end, I torched it well enough that the aluminum actually began to melt. Okay, and as soon as that happens, what happens is the aluminum starts to evaporate out the flame. And let me blow that up a little bit. You take a look. We'll get some light on there. Ah, gosh, where'd it go? Light. Wire. And now I can't melt the aluminum wire with my 1300 degree torch, because 1300 degrees Celsius is about 250 degrees less than the melting point of palladium. And AuPd actually melts above that. And so what I have here is a precious wire of palladium, basically. It's got some gold in the planes of cleavage in between the cubic structure of the palladium. And it makes rainbows because those little cubes are half the size of a wavelength of visible light. And it creates Bragg diffraction. Cool, huh? So, and that's how I know it converted into AuPd, because before that it did not make rainbows. And you could bend it a few times and it would break. And now I can bend it and bend it and bend it and bend it. And I can break it with difficulty if I kink it first. But otherwise, like it's in a spiral now, and I can straighten that out and make it absolutely perfectly straight, so you couldn't tell that it was all, woochly-doochly like this. And bend it again and reuse it hundreds and hundreds and hundreds of times for all kinds of different things, man. This wire is the handiest wire I have ever had in my life. And you can use it for anything. And the total cost here was just about zip, because I made it from a $5 roll of clothesline and some kaolinite clay. And you can see that the kaolinite clay didn't go away. I mean, it did. It went in here. It replaced this. Most of the weight of this is now AuPd. It cascades. Once the AuPd moves into this, it has such a high melting point, the aluminum just starts melting away from it. And the aluminum travels towards the heat. And it goes up and out the flame, and it leaves the higher melting point, AuPd. I don't think it's AuPd. I know it is because I tried to melt this other end. And I heated this section up right here where it bends with the same flame that melted the other end. And I couldn't do it. Couldn't melt it. even though I know for sure that flame is 1300 degrees Celsius. Aluminum melts at 650 degrees Celsius. Gold melts at 1050. Just over 1050, 1065, something like that. And you can see the kind of goldy color right there. That's what that is. It's gold that's evaporating out because it's got a lower melting point than the palladium. So there it is, AuPd wire. And I can now stick this in some 3% solution hydrogen peroxide, yeah? And it will make new hydrogen peroxide. All I got to do is just keep adding water. And from hydrogen peroxide, platinum in my AuPt will split that peroxide into 2 hydroxyl ions, which is hydrogen-oxygen gas, which is your basic rocket fuel from a catalyzed reaction from the dust on the side of the road. Far out, man.